Hello everyone! So in this video we are going to be talking about imine formation. Now in organic chemistry there are a variety of nitrogen nucleophiles such as primary, secondary, or tertiary amines that can add to aldehydes and ketones. Imines specifically are going to be formed from a primary amine, which we have right here, reacting with an aldehyde or ketone. So in this case we have a ketone. They contain a carbon-nitrogen double bond, which we can see here, and they are important in a variety of enzyme mechanisms. Another name for these molecules is Schiff bases, so if you take biochemistry, you may hear them called that in that sort of context as well. Now, as far as mechanisms go, our mechanism for converting our aldehyde or ketone in our primary amine to our imine can get a bit long. However, there is one key thing to keep in mind. We are going to want to protonate to get rid of and deprotonate to keep. You'll see what I mean as we work our way through the mechanism. Now, I have laid out a little guide for me so I can kind of keep track of what's going on. But overall, our mechanism is going to be characterized by the nucleophilic addition of an amine and the loss of water. Now, starting off with our ketone, we are going to add our nucleophilic primary amine, which is going to attack the electrophilic carbonyl carbon, pushing those electrons up onto oxygen, leaving us with a negatively charged oxygen that has that extra lone pair and a positively charged amine group. Sorry, it takes a second to draw these out sometimes, keep track of everything. Now we have that positively charged amine group attached to what was that carbonyl carbon. Next, we are going to add a base, which is going to deprotonate our amine, making that positive charge neutral. We still have a negative charge on oxygen though, don't forget about that because we haven't done anything with that quite yet. So there we have our neutral amine. Next we are going to add an acid, which is going to protonate our oxygen, forming an alcohol group. Remember what I said, that we are protonating to get rid of, deprotonating to keep? We want to keep that amine, so we're deprotonating it. We want to get rid of our oxygen eventually, so we're protonating it. So next we are going to add more acid, which protonates our oxygen again, forming water. And if we remember anything about water, water is a really good leaving group. So once we have formed our water, and then we still have our amine, that water is going to leave our molecule. That's going to be our leaving group. So once water has left, we're now left with something that looks a little bit like this. And that carbon that was our carbonyl carbon is now positively charged. Now, through resonance, we can take that lone pair that's on nitrogen and drop it down to form a double bond between carbon and nitrogen, leaving our nitrogen with a positive charge instead of our carbon. Finally, in our last step, we are going to add even more base, which is going to deprotonate that nitrogen, making it neutrally charged once again, and leaving us with our imine product. Now, I know this mechanism has a lot of steps. However, we just need to keep in mind that we are protonating to get rid of and deprotonating to keep. Now, one last note that I want to make is that this process is reversible due to imines being able to be hydrolyzed back to their corresponding primary amines under under acidic conditions, which is why you will see that all of the arrows go forwards and backwards. All right, moving on to some practice problems. I have a few practice problems for you to try when you are figuring out the product of that ketone reacting with the primary amine. And the second problem, we have an aldehyde, we have our imine product, and you have to figure out what your primary amine is that you are reacting with your aldehyde. So I will have answers posted to those. All right, so these are the answers that you should have gotten for those practice problems, and thank you so much for watching.